Okay, welcome to today's video. So in this video we're going to see an example of the relationship between the roots of a polynomial and the coefficients of a polynomial. Now you might have seen some of these in your 3-unit maths, although these questions are slightly more difficult. So the question says, if alpha, beta and gamma are the roots of the equation x cubed plus 2x squared minus 5x minus 6 is equal to 0, find alpha squared plus beta squared plus gamma squared, 1 over alpha plus 1 over beta plus 1 over gamma, 2 plus alpha times 2 plus beta times 2 plus gamma, and alpha cubed plus beta cubed plus gamma cubed. Now I've already done the first step of this question, which is just something that you should know from your 3-unit maths. That is finding the value of these three fundamental expressions. So alpha plus beta plus gamma, that's the sum of roots 2 at a time, and the product of roots. And these are the values for them. And I guess it's quite important to note, if you wanted to generalize this, finding these for any polynomial of higher degree than 3, you should just note the alternating sign of minus b over a, plus positive c over a, and negative d over a. But anyway, let's get into the question. So, the first one is alpha squared plus beta squared plus gamma squared. Now, we need to find an expression for alpha squared plus beta squared plus gamma squared in terms of these three, or some of these three fundamental expressions. Okay, and the way we do this is like this. So let's consider this, alpha squared plus beta squared plus gamma squared. We need to think of alpha plus beta plus gamma all squared. So this is equal to, I'll just write it like this so it's easy for us to see how to expand, alpha plus beta plus gamma. So to expand this, which I'm sure everyone knows how to do, you just distribute the alpha through this parenthesis, the beta through this parenthesis, and the same for gamma. So alpha squared plus alpha beta plus alpha gamma plus beta alpha plus beta squared plus beta gamma plus gamma alpha plus gamma beta plus gamma squared. Alright. Okay, now we can collect like terms. Now you'll see that alpha squared plus beta squared plus gamma squared are in this expression. So we can write them at the front here. And when we collect like terms, we'll see that all of these alpha beta, alpha gamma, and beta gamma, they have a factor of 2. So we can factor that out, and we get alpha beta plus alpha gamma plus beta gamma. Okay, but we know from previously that alpha beta plus alpha gamma plus beta gamma is equal to minus 5. And so we get alpha squared plus beta squared plus gamma squared plus 2 into negative 5. But what's this equal to? This is equal to the sum of roots all squared. And we have that the sum of roots is minus 2. So all of this is equal to minus 2 squared. Now when you take all the constants to one side, you'll find that you get alpha squared plus beta squared plus gamma squared is equal to 14. And that's your final answer. Okay, the second one, 1 on alpha plus 1 on beta plus 1 on gamma. Alright. If we make a common denominator here, we can get alpha beta gamma on the denominator. And as the numerator, well, to get alpha beta gamma as the denominator of the first fraction, we have to multiply top and bottom by beta gamma. For the second one we need to multiply by alpha gamma, and for the third one we need to multiply by alpha beta. But you could just recognize this as the sum of roots 2 at a time over the product of roots. And again, we look back to our three fundamental expressions. So the numerator is going to be minus 5 and the denominator is going to be 6. So we get minus 5 over 6. Okay, the next one. 2 plus alpha, 2 plus beta, and 2 plus gamma. Okay, so the first step here is to expand this out. So if we just expand the first two brackets, that's 4 plus 2 alpha plus 2 beta plus alpha beta. And I'm going a bit quick here because I'm sure you know how to expand brackets. Now if we expand these two brackets, we get 8 plus 4 alpha plus 4 beta plus 2 alpha beta plus 4 gamma plus 2 alpha gamma plus 2 beta gamma plus alpha beta gamma. We can collect like terms and we'll see that we get a factor of 4 here. So 4 into alpha plus beta plus gamma, plus we get a factor of 2, alpha beta plus alpha gamma plus beta gamma, and we get a product. Now, once again, we have values for these from our three fundamental expressions. So, this is 8 plus 4 into alpha plus beta plus gamma is negative 2. The sum of roots 2 at a time is negative 5. And the product of roots is 6. So, we get 8 minus 8. 2 times minus 5 is minus 10 plus 6. And that is equal to negative 4. So that's the third one. So we just had to expand it and sub in our values. Now the last one is a little bit different to the other three. So it's alpha cubed plus beta cubed plus gamma cubed. Now you could go ahead and get an expression for alpha cubed plus beta cubed plus gamma cubed by doing so alpha plus beta plus gamma all cubed, but then you'd have a lot of simplifying to do and you'd get quite a large expression and there's a high chance of making a mistake. But there's a different way to do these questions and you can extend it to degree 4 and degree 5 and so on. If we have a look at the original polynomial, or the original equation, this equation here, this has roots alpha, beta, and gamma. So what does it mean for it to have roots alpha, beta, gamma? We can substitute in x equals alpha here, and that'll still be equal to 0. So let's substitute x equals alpha, and we'll get this expression. Let's call that equation 1, and let's do the same thing for beta. Call that equation 2, and finally the same thing for gamma. Oh, that should be a squared. 5 gamma minus 6 equal to 0. Call that equation 3. Now we want alpha cubed plus beta cubed plus gamma cubed. Now you can notice that if you add up these three equations, you're going to get just that. You're going to get alpha cubed plus beta cubed plus gamma cubed, plus we can factor out a 2 and we get alpha squared plus beta squared plus gamma squared. We can factor a minus 5 and we get alpha plus beta plus gamma. And if we factor a minus 6, so we get minus 6 and we get 3 lots of the minus 6. Okay, so alpha cubed plus beta cubed plus gamma cubed plus 2 into. Now, if we look back to question 1, we actually worked out the value of this, alpha squared plus beta squared plus gamma squared. We worked that out to be 14. So we need to use that here, and we get 14 minus. Now 5, once again, look back to the 3 fundamental ones. The sum of roots was equal to minus 2. So 5 into minus 2. And minus 6 times 3 is minus 18. It's equal to 0. I'm just working out the value now. So 2 times 14 is 28. Negative 5 by negative 2 is positive 10. And here we have negative 18. If you simplify that, you will get alpha cubed plus beta cubed plus gamma cubed is equal to negative 20. And that there is your final answer.